Despite the fact all organizations do it, a tech transformation, evolution, or modernization initiative should not require you to rewrite your business rules. We do it all the time though, right? If you're going to Spark, if you're on Spark and you're going to AWS, something happens, they probably just assign it to another team and you rewrite your business rules. If you're going to Kubernetes, somewhere in it, you did all this stuff to abstract it at the beginning of the project, but the next person who takes it rewrites your business rules. Domain-driven design, in Wikipedia it states, domain-driven design is predicated on the following goals: placing the project's primary focus on the core domain and domain logic, and basing complex designs on a model of the domain, and initiating and creating collaboration between technical and domain experts. I'm going to cut that part short, because this is what I really want to focus on. One more time, for all you in the back. Wikipedia says domain-driven design is predicated on the following goals: placing the project's primary focus on the core domain and domain logic. Your core domain is where the value exists. It's not in your deployment to Spark. It's not the fact that you run on AWS or Azure. It is the thing that makes your business and your company unique. So the core domain is where the value of your organization, the department, and your project exist. So why do we re-implement it? Why do we re-implement our core domain over and over again? Across departments, when we change execution environments, or even when we change programming languages. So I'm going to talk a little bit, very briefly, about business rule engines, BRES. I'm probably not going to use that acronym, but if you see it elsewhere, don't want to read all this, but Gardner defines a business rule engine as what is above. Basically, it allows you to execute, define, manage, and automate your business rules. And there's different types of these engines: script-based, declarative, hybrid. You may have seen things that are low code or no code, full platforms that require you to integrate fully, source code. They allow you to automate. They can be embedded. Sometimes you have to do platforms as a service or code as a service. They come in many forms. And business rules engines help you capture the logic of your core domain. So I want to introduce you to something known as Morphir. Morphir is, I don't have it on here, but it's an open source project under the FinTech open source organization. It was actually donated from Morgan Stanley, where I used to work. It allows you to capture your logic, your, wait for it, business rules in a data format. So what is Morphir? Very simply, it's functional domain modeling, right? I like domain-driven design, and if you put another spin on it, functional domain modeling. There's a great book by Scott Woloshin, which is Domain Modeling Made Functional. We read that book and we really took it to heart. So Morphir allows you to model your domain in a pure functional manner. It provides a data format, an intermediate representation in IR for capturing logic. Its code is data, right? It's not just another IDL where you get interfaces and schemas, but you actually can capture logic. It's open source, as I mentioned, and it's used by enterprises. Started in Morgan Stanley, was open sourced and donated to this Finos organization, which is a member of the Linux Foundation, and organizations like myself at Capital One, we're using Morphir as well. And it's really about abstraction. I heard abstraction in the previous talk, and it's focused on abstracting business logic from your execution platform and your tech choices. What are the core principles or core concepts? Types, I saw that on the last slide as well, or in the last talk. It defines data models, schemas, data, and operational contracts. It also has values, right? So this is what I was talking about. Provides the ability to capture values, define functions, and not just signatures, right? So it's actually, it's for every IDL you can think of, be it Protobuf, be it Avro, be it even Smithy. Great formats, right? But they they define schemas and signatures. But Morphir actually captures your business logic in its data format. It also provides modules. Last talk, I keep going back to it. Modules are really important, and if you go above and you're able to have components to encapsulate your types and your values, it's really important for shareability and the ability to distribute things. Real quick, this Morphir thing I'm talking about, you can think about it just as a compiler pipeline. If you have ever compiled code, you've seen it. So it's front-end language that gets transformed into this data format, this intermediate representation, and then you can just use it in the backend. What kind of backends? Well, you can generate code from this IR format. You can generate Scala, TypeScript, JSON schema, and it's open source, extensible, so you can actually add your own backend. And that's really a big value add, and part of it being open source is if a developer, a bunch of developers are willing to do a transformation to take the IR and to map onto your execution platform or a visualization, then you can keep the same business rules, but you can write essentially just a transform or code gen for your target platform. So exploring Morphir. So our story continues. At the northest of poles, where things often get cold, a buzz arises with talk of a heist. The algorithm stolen, who'd be so emboldened to steal lists of who's naughty and nice. At such late stages, amidst technology changes, the sentiment data to crunch, a trusty wise elf, not managing a shelf, shares his heartfelt hunch. Not being nostalgic, but Morphir has the logic captured and stored onto disk. Amidst all the changes and versioning ranges, someone mitigated the risk. Now, quick demo. This is where I hope oh, awesome. Except for one thing, not what I want to show. All right, so hopefully it's big enough. I think I did make it plenty big. Awesome. So Morphir allows, I went through it really quick, it allows you to take a front end and to create this data format. And the IR, this intermediate representation, is actually a pure functional IR, and it has pure functional capabilities. It actually maps almost 95%, maybe even a little bit more, to the Elm programming language. So our first front end that we built out the box was in Elm. But don't worry. Well, first of all, I'll say something about Elm. Elm is pretty simple. It's a simple functional language that is purely functional. And your business logic, if you think about it, your business logic does not need to talk to a database. It shouldn't need to integrate with the cloud. In fact, I've worked on systems and people had performance issues. What was the performance issue? In the middle of their business logic, they were calling out to an Oracle database. And they were like, why is it every time that we go, why is our business logic taking so long to execute? Well, you can fix that. So we see this in Elm, and I'm just going to show some features really quick that Morphir provides. You can do the sort of things you'd expect to do. You can make enumerations, right? The overall sentiment, naughty or nice, you might sense a theme here. You can also list in those enumerations, let's say we have some activities. Made a bed, brushed teeth, maybe stole some presents, or hit their kid's sister. And you can take all that, right? I'm going really quick to make sure that we have time here. But you can also not only define types, like I said, right? Let's show another sort of type that we can define a little bit more. You can do type aliases, right? I can say age is an integer. I can say first name is a string, so on. Some more enumerations. But I can do records, right? And I can use my own types in the records. Guess what? The format also includes enumerations, unions, discriminated unions, whatever you want to call them, tagged unions, right? They're all there. And here's the part, right? This logic is going to be captured in the format. So I set up a little build step. So let's just do a quick gulp build. Let's shut that down. And one of the backend that we provide is this ability to kind of look at your data. And so I talked a bit about this format. And you'll see all of these different modules are listed here. You can see the main module. How about we look, I had that sentiment thing, right? I've got values that were in that module that I didn't go over, but I can say overall sentiment, if you remembered, it was on the screen before, naughty, nice, right? If I go into my activities, I can look and, hey, I've got, brush teeth, did all this stuff, stole presents, made a bed. If I look at a person, we've got, once again, types and values here. If I look at a person type, person is either a Grinch, which requires an age, or they're a who has a first name, last name, age, and maybe they have a title. Let's look real quick at some simple logic, right? Simple logic, maybe I want to know what's the name of somebody. Visualization, because you've got code as data, you can actually visualize logical branches really easy, right? So this is actually the logic that was captured in the Elm code before, where how you construct a name, right? And it turns out that the Grinch, we didn't give it a name, but hey, we decided he's always referred to as the Grinch, except in the case where we're saying title is string. And here's some things that I kind of glossed over before, but there's pattern matches in here, right? So we're seeing these cases, and that's all part of how you can represent your logic. Yeah, pure functional, the stuff you expect from a pure functional domain, it's all here. And it's visualizable. If I really drill out and go to the highest level, I decided I was going to define the sentiment algorithm, which in my rhyme, maybe you missed it. Someone had kind of lost track of the sentiment algorithm. And here it is. Here's my default algorithm that I can actually look at and say, hey, you can change the algorithm, and this is often what will happen in a business context. And my algorithm is really simple. If you did something naughty, you're naughty. Or if you're the Grinch, you're also naughty, right? And let's drill in a little. Here's how you actually see that, all right? The implementation of my function. If my activity is naughty, right, of all my activities, and any of my activities is naughty, then it's going to naughty. You don't believe me? All right, let's see. If I'm the Grinch, let's say the Grinch is 99 years old, and it doesn't really matter what he does. I'm the Grinch, and I'm gonna, let's say I made my bed. I'm naughty, and that's not a naughty activity, but nevertheless, I'm the Grinch. Hey, by the way, let's just save this, the Grinch. Morphir allows you to save test cases. I don't have as much time, but it's saved here. And yeah, I've got some test cases. I can do one more example. Let's say I'm a who. Let's say my name is Cindy Lou. Last name is who. Let's say I'm 8 years old. And I don't have a title, right? And let's give Cindy some activities. If you look, by the way, up here, you can see your logic is kind of lighting up, so you can see exactly what was going on. And let's say that she brushed her teeth. She's nice. I didn't mean to delete that. Come on. Let's say, all right, she brushed her teeth. She's nice. Let's add another one. And let's say she made her bed. Still nice. Anybody want to pick one of these out of the options? Shout it out. Stole presents. She's naughty. Really simple, contrived example. It's really good for demos, right? Contrived examples. But imagine now this logic and this capability in your core domain with your business logic. And all right, I'll show probably one more little feature. We want to be able to eventually do code generation, so you're actually able to have these sidecar files that as much as you create your IR files, you might have your own data. And what I'm showing here is I actually made a sidecar file that has this additional property that I can tag to certain things. So I'm going to look at my types in person, and I'm going to say, okay, age. I'm going to say that it's actually, I already did this, I should have deleted the file. It's an opaque type, and I'm going to say, just for the heck of it to show, I can say that person is not an opaque type. That extra bit of data that's stored, it can help you that you can essentially extend the IR and use the data in your own context. And last bits, what you saw me running was I ran the Morphir Elm develop command to see visualizations, but in addition, you can do some things that are probably meaningful. You can, let's just expand this real quick. Few options, and as I hurry to a close, generate Scala code, generate JSON schema. You can create Docker containers, do some test data. Let's really quick, based on all the types that are there, I can do something where I generate some JSON schema, and if I look where I generated from my models in my distribution folder, I'm going to see this JSON, and it is, yep, it is, come on, help me out here. You'll see, my union types are all there, so on and so forth. And I can also generate, if you saw in the help, this is functional Scala. So of course, really important for functional Scala is to be able to generate Scala code. And here we go. Just so you don't see IntelliJ give massive squigglies, because I don't have a build system set up for that generated code right now, I will show you that, hey, here's my activities, here's, once again, the type of activities I had, here's my person, who's I've got some type aliases. And all of this is just a code generation backend. In the end, sort of things that we're working on and really coming to a close with all this is, Morphir is a way that you can capture your business logic in a pure functional data format, and through the power of transformations, you can finally get to the place where you write your business rules once, and rather than rewriting business rules where the risk is, you can write a code gen or tooling to do the transformation to create the deployment and execution environment. You only probably need to do that one time. You spend some effort there, but you're not rewriting the core domain where you can make mistakes. Because if you have to rewrite GDPR and you mess up, some governments might be angry. Just want to say real quick, thanks to the organizers of Functional Scala, to Morphir maintainers and contributors, to all the Capital One associates. I didn't mention real quick, but Morphir, there's a ton of repos. You'll see links here, and we've got things on the horizon working on Morphir.net port. We're also looking to do Rust and WebAssembly integration. Thank you for listening. Have a great Functional Scala.